Here in this session, we're going to be adding and subtracting fractions together. Very simply, we're going to start off with arithmetic, which you've already had to this point, as a quick reminder, because the same principles apply when adding and subtracting algebraic fractions. First of all, in order to add or subtract fractions together, they have to have the same denominator. Here, 7/12 and 4/12. Our denominator is 12 in both. They're the same. So to add fractions together to have the same denominator, you simply take their numerators and add them together. 7 plus 4 is 11. So that becomes the new numerator. And then you simply keep the denominator. Since it's the same in both, you just simply keep it the same. 7 over 12 plus 4 over 12 equals 11 over 12. If I were to write that using variables instead, we have A over B. And if we had that and we're adding to it C over B, that's going to be the same thing as A plus C over B. In our example here, 7 over 12. The 7 is our A. Our denominator 12 is our B. Then in our second fraction, 4/12, 4 is the C, 12 is the B. So you do not add denominators together, you add the numerators together. So A plus C being represented here, and then B just remaining as itself in the denominator. A over B plus C over B is equal to A plus C over B. Next, we have two fractions that do not have the same denominator, so we have to get the same denominator in both of them. And we do that by multiplying both the top and bottom by the same number. So I'm going to rewrite this here as 2/3. Now to this fraction, we come to our second fraction and take the denominator. That 7 is what we're going to multiply both the top and bottom by. Then we're going to take that and come to our second fraction, which is 6 over 7. And what we're going to do is take the denominator of the first fraction and multiply the second fraction by that same number, top and bottom. So we're going to multiply by 3 over 3. By multiplying 3, 6 times 3, 7 times 3, we can now simplify after we've combined this together. First of all, we multiply numerators together. 2 times 7 is 14. That's our new numerator. Our denominator is 3 times 7, which is 21. Then we're going to add to it 6 times 3, which is 18. And 7 times 3 is 21. Now, since we have the same denominator, we keep that denominator the same, and now we simply add our numerators together, which gives us 32, because 14 plus 18 is 32. So I just went ahead there and erased that bottom work that I just showed, because what I want to do is in the second example is do what we did here in the first. I want to rewrite what we just did here using variables. Okay, here though we're starting off with two fractions that do not have the same denominator. So what we have going on here is our first variable, the top will be A, and the bottom will be B. So in this example here, 2 is representing A and 3 is representing B. But as an algebraic statement, A over B plus C over D. Notice here that B and D are not the same. We have different denominators. But that is going to be the same thing as A times D over B times D. Because remember, to make that equivalent fraction so we could create the same denominator, we take our denominator of our second one and we multiply both top and bottom by it. So that's what we've done here. We've taken our D times our A and our D times our B. That becomes the first part. Then we take our second fraction and multiply it by this denominator down here, the B. So we are going to be taking C over D, and that's going to be multiplied by b over b. Now at this point, since we have the same denominator in both, b times d, we can now combine numerators together. A times d is AD. C times b is just BC. Then in our denominator, b times d is just BD. So in this case, when you start off with denominators that are different, a plus b over c plus d, that corresponds to AD plus BC over BD. Okay, let's do a couple quick ones here and finish up this session. 4x plus 5, 4x over 5 rather, plus 6x over 5. First thing you should notice is that we have the same denominator. So when you have the same denominator, you just rewrite the denominator. And then you simply add your numerators together. 4x plus 6x is 10x. Now, if we notice here, though, we do have a common factor between our top and bottom. So we should probably go ahead and reduce this by dividing our top and bottom by that greatest common factor. Well, 5 is not only a factor of 5 in the bottom, but 5 is also a factor of 10 up here. So what we're going to do is divide both the top and bottom by 2. And we're going to do this in our head. What is 10x divided by 5? Well, that's 2x. And then what's 5 divided by 5? That's 1. So then 4x over 5 plus 6x over 5 equals 10x over 5, which reduces to 2x over 1, which is simply the same thing as 2x. 2x is our answer. Here in this second example, we're going to be we're going to be subtracting instead of adding, but we also have two fractions that do not have the same denominator. So we're going to use our method here that we outlined earlier. In order to get the same denominator for both fractions, we're going to take our denominator of our second one and multiply our first fraction by that in the top and the bottom. So we're going to have 4 over 4. If it helps you to think of it, 4 times 2x minus 1 in the top, and then 4 times 6 in the bottom. The main reason I keep emphasizing that it's 4 over 4 is just to remind you that what we're really multiplying is by 1. And by multiplying by 1, we have not changed the value of our fraction at all. So that's our first 4 over 4 times 2x minus 1 over 4 times 6. If we go ahead and carry that out, we are going to be left with 4 times 2x distributed out is 8x. 4 times a minus 1 is a minus 4. And then in our bottom, we're going to have 4 times 6, which is 24. So what I'm going to come over here and do is rewrite 2x minus 1 as 8x minus 4 over 24. These two fractions are equivalent. They're the same thing. Let's come to our second one here. X over 4. I'm going to rewrite that down here. X over 4. And what we do here is we take our first denominator of our first fraction, 6, and we're going to multiply top and bottom by 6. 6 times x is 6x. That's our numerator. Our denominator is 4 times 6, which is 24. X over 4 is the same thing as 6x over 24. So I'm going to go ahead and rewrite this over here. 6x over 24. These two fractions are equivalent, and there's our minus sign. So what we've done now is we've rewritten these two fractions as equivalent fractions that both have 24 in the denominator. And because we're running out of room here, I'm just going to go ahead and wipe that out. Now let's go ahead and actually perform the calculations here. Since we have the same denominator, 24 remains in our denominator. Now we do our numerator. 8x minus 4 minus 6x. Well, it doesn't matter which order, so let's do the 8x minus 6x first. That'll be 2x minus 4. Remember, when you subtract, that's the same thing as adding the opposite. So what I really did here is 8x plus a minus 4 plus a minus 6. I just took our plus a minus 6 and combined it with our 8x, which left us our 2x. Plus a minus 4 is the same thing as simply minus 4. So at this point, we've calculated or carried it out, but we can actually divide both the top and bottom now by a common factor. And the greatest common factor, let's go ahead, before I indicate what the greatest common factor is, let's factor our top. 2x minus 4, both the 2x and the 4 have a common factor of 2. So we're going to bring that out, and that now leaves us with x minus 2 on the inside. 2x minus 4 is the same thing as 2 times x minus 2. And in the bottom, we also have a factor of 2. 2 times 12. This 2 and this 2 cancel. Instead of crossing it out, I'm just going to erase it here. That 2 cancels out with this 2. So what we're simply left with then is x minus 2 over 12. 2x minus 1 over 6 minus x over 4 is x minus 2 over 12. As a review, in order to add or subtract algebraic functions together, they must first have the same denominator. And then as a restatement of what I had on the previous couple screens, a over b plus c over d, you have two different fractions with different denominators, is going to be AD over BD plus BC over BD, which then corresponds to AD plus BC over BD. That'll wrap up session 74.